Hello everyone, welcome back to the maths class. Today I am going to explain exercise 6th H. In this exercise you are going to study inverse of an n cross n matrix, n by n matrix we can say, and second thing properties of matrices and inverses. So first of all, how to find inverse of an n by n matrix means you have to find in last video I told you how to find the inverse of a square matrix of order 2. Now I am going to tell you how to find the inverse of a square matrix of any order. Of any order means it may be of order 2, it may be of order 3, it may be of order 4, it may be of order 5, like this. So that's why inverse of an n by n matrix I have written. So now you see how to find inverse. Suppose a square matrix A of order 3 is given. Square matrix A of order 3. Then A inverse equals 1 upon determinant A into adjoint A. Yesterday I told you how to find adjoint A. In last video I told you how to find adjoint A. So you divide adjoint A by determinant A, then you will have the inverse of given square matrix. Now properties, only this formula is there, and in last video I told you inverse will exist if and only if this determinant A is not equal to 0. Means given square matrix should be non-singular matrix. If it is singular matrix, then its inverse will not exist. So when it will be singular, if determinant A is equal to 0, then it will be singular. If determinant A is not equal to 0, then it will be non-singular. So if it is non-singular matrix, then 100% its inverse will exist. And how can you find? By applying this formula, A inverse equals 1 upon determinant A into adjoint A. Adjoint A, how can you find? In last video I told you. For this you can see again one time if you have forgot how to find adjoint A. So one time you can see last video. Now properties of matrices and inverses. Two properties are there only. First property, if A and B two n-rowed non-singular matrices, then AB is also non-singular and AB inverse equals B inverse into A inverse. A reversal law for the inverse of a product means, first of all, two matrices, you should have two square matrices of same order, and wrote two non-singular matrices they are saying. So two square matrices of same order you should have. Then product AB you are finding, and its inverse if you are finding inverse of product of A and B, then it will be product of separately inverse of B and A, means inverse of B multiplied by inverse of A. This is first property. Second property, A dash inverse equals A inverse dash, means inverse of transpose of A equals transpose of A inverse. One more time I am telling to you, inverse of transpose of A equals transpose of A inverse. This property. Second property, and there are two properties only. So some examples I am going to take based on these properties. You can see properly these examples. So first example is 87. Find the inverse of matrix. This matrix is given and verify your answer. Verify your answer means whatever inverse you are finding, that is correct or not. So for this, in last video I told you, you can suppose this matrix as A. So A equals given matrix 1 0 3 minus 1 2 minus 2 2 minus 3 4. Now first of all you have to check its inverse exists or not. So how can you check? You can find determinant a like this, and this determinant, you know how to expand. 1 into 8 minus 6 plus 1 into 0 plus 9, and then plus 2 into this 2, 0 minus 6. So it is coming 2 plus 9 minus 12 equals minus 1, which is not equal to 0. It means that its inverse exists. And when its inverse exists, you need to find adjoint A. So to find adjoint A, you need the cofactors of all the elements of this matrix, this given matrix. So cofactors first you are finding, you can see here A11, it is coming 8 minus 6 2. Yes, in last video I told you how to find cofactors. A12 minus 9, A13 minus 6, A21 0, A22 minus 2, A23 minus 1, A31 minus 1, and A32 3. Then you can make adjoint A. Here you can see adjoint A equals transpose of the matrix of cofactors. So cofactors matrix 2 minus 9, these are the cofactors 2 minus 9 minus 6, 0 minus 2 minus 1. These are the cofactors of all the terms given in the given matrix. Its transpose you are taking, so this is coming adjoint A. Now you divide this adjoint A by determinant A. So by minus 1 you will divide. By minus 1 means you can change the sign of all the terms in the matrix. So you are changing, 2 is becoming minus 2, 0, 0, and minus 1 plus 1. So like this you are finding the inverse. After finding this inverse, how to check? So A inverse you are having, A is given. So if A multiplied by A inverse, you can see here A multiplied by A inverse multiplied by A equals I. If it comes, then you can say your inverse is correct. So A multiplied by A inverse multiply, how to do, you know very well from class 10th. So it is coming 1 0 0 0 1 0 0 0 1. It means that I3, it is coming I3. I3 means I, unit matrix. Now A inverse A, then also it is coming 1 0 0 0 1 0 0 0 1. It is coming I. So it means that your inverse is correct. In both the cases, A inverse A equals A inverse equals I. Second example you can see. In second example, A is given, B is given. Verify AB inverse equals B inverse A inverse. Just before I told you the property. So first of all, product of AB you find. Product of AB, you know how to find. 0 to 2 7 it is coming. Product of AB. Now inverse of AB you have to find. So first of all you check its inverse exists or not. So determinant AB you find. Determinant AB, you can see here it is given. Determinant AB equals 0 to 2 7, cross by cross multiplication 0 7 7 minus 4, sorry 0 7 0 into 7, 0 minus 4 minus 4, which is not equal to 0. It means that its inverse exists. So its inverse you find, actually it is a 2 by 2 matrix, means square matrix of order 2. So its inverse, as I told you in last video, by that method you can find, means you can interchange the elements of leading diagonal, and you can change the sign of the elements on other diagonal. So here you can see you are changing the element of leading diagonal, and you are changing the sign of elements on other diagonal, and you are dividing by determinant AB. So this is the inverse. Now A is given, determinant A you check, it is coming 2, which is not equal to 0. It means that A inverse exists. So A inverse you find, adjoint A you are finding. Adjoint A in the same way as I told you. You take first you interchange the element of on the leading diagonal. You can see here 2 1 is there, here 1 2 is there. You have changed, and sign of because you have to take the transpose sign here you will change. You are taking interchanged way. Oh, they are finding adjoint A. Adjoint A, as I told you yesterday, in the same way, A11, A12, like this you can find. So on then you can take transpose. So it will come 1 minus 3 0 2, means in the same way you can see 2 1 1 2, and you are changing the sign of the elements on other diagonal. Now inverse you are finding adjoint A upon determinant A, so it is coming inverse. In the same way, for B you check determinant B is minus 2, it is not equal to 0, B inverse exists. So B inverse as A inverse you found. In the same way you find. Now multiply B inverse A inverse. So B inverse is this one, A inverse is this one. You multiply both. So it is matching to, you can see here, you can see this one and this one. It is matching. This one and this one. This one and this one, they are matching. So like this it is verified. You can solve such type of questions. Now one more example is there. For the matrix A, after that I will take this example, one more example after this. 90 example I am taking. For the matrix A equals this, A square minus 4A plus 5I equals 0, you have to show. So it is very easy. A square you can find A multiplied by A. This is A square minus 4 into A plus 5 into I. So solve it. A square, it is A square 1 minus 2 minus 1 minus 3, 2 plus 6 minus 2 plus 9, and it is minus 4A and it is 5I. So after simplification you are seeing it is coming 0 0 0 0, means 0. So such type of questions in previous exercises you have done. Now after this you have to find A inverse. Now A inverse you have to find with the help of this, A square minus 4A plus 5I equals 0. With the help of this you have to find A inverse. How to find A inverse you can see here. It is new thing for you. It is written pre-multiplying both the sides of A square minus 4A plus 5I by A inverse we obtain. Pre-multiplying means A inverse you have to write before the term. So A inverse into A square minus 4A inverse into A plus 5A inverse into I equals 0. Both the sides you are multiplying, 0 multiplied by A inverse 0. Now A inverse into A square. So power of A, one power of A will cancel. So like this you can see here. A inverse A is I. Here it is written A inverse A is I. So 1A and 1A inverse, they will make I. And here A inverse A, you can see here this term and this term, 4I. Because A inverse A is written, 4I will come. So it will become I. Here also A inverse I equals A inverse. If you multiply any matrix with identity matrix, same matrix comes, you know very well. So that's why it is A inverse. Now it will become IA, first term, second term 4I, and third term plus 5A inverse. Plus 5A inverse you leave here, and these two terms you take on other side. So this will come 5A inverse equals 4I minus A. So you can put the value of I, 4 into I minus value of A. So 4004, it will become minus A. After subtraction it will come 3 minus 2 1 1. Now by 5 you can divide. So A inverse equals 1 upon 5, 3 minus 2 1 1. So like this you can find inverse with the help of the given equation. One equation was given, matrix equation was given. With the help of this equation, by pre-multiplying or by post-multiplying also you can find. Now next example, this one 93. For the matrix A equals 3 7 1 5, find x and y. A square plus xi equals ya. This condition is given. A square plus xi equals ya. So a square a multiplied by a plus x into I 1001 equals y into a 3715. So multiply. So 9 plus 7 21 plus 35 3 plus 5 7 plus 25 plus x 0 x equals 3y. You multiply by y 3y 7y y 5y. So it will come finally 16 plus x 8 56 32 plus x equals this one, means 3y 7y y 5y. You make the comparison. If you make the comparison, then you will get 16 plus x equals 3y, 8 equals y. So 8 equals y, value of y you have found. Now this value of y you can put in equation 1. 16 plus x equals 3y. So 16 plus x equals 3 into 8. So x equals 24 minus 16, 8. So y equals 8, x equals 8 you have found. Now after this you have to find a inverse also. So first of all, before finding a inverse, you will have to put the values of x and y in the given matrix equation. In this equation you put the value. So you are getting a square minus 8a plus 8i equals 0. Now this equation has become the equation of previous question, as you have done in previous question. In the same way you are having the equation, you multiply both the sides. Pre-multiplication you can do by a inverse. So when you do pre-multiplication, you will get, here you can see, a inverse into a square minus 8a inverse into a plus 8a inverse into I equals 0. A inverse into a square, it will become IA. You can see here. You can see a inverse a. 1 a inverse a is becoming I and 1 a is going on. So IA. Now next term is a inverse a I. So it will become 8I, you can see. Plus 8 a inverse I is a inverse. So 8 a inverse. Now 8 a inverse you leave here and remaining terms you can take to other side, like this you can see. 8 a inverse equals 8I minus a. Now value of I you can put, value of a you can put, and simplify it. So you are getting 5 minus 7 minus 1 3. 5 minus 7 minus 1 3 divided by 8. So it is coming a inverse. 1 upon 8, 5 minus 7 minus 1 3. So like this students, such type of questions you are going to get in exercise 6th H. And in this exercise, after getting this video, you will be able to solve all the question of this exercise 6th H. And I think you have understood all the points which I explained through examples. So if you have any doubt, you can ask. So you can solve all the question of the exercise. So thank you. Wish you all the best.